So today we are going to discuss the finite automata basics. So how we can represent finite automata, what are the different types of finite automata. So these are the things I am going to discuss. So please join quickly and mark your presence. I hope I am audible and visible to every one of you. So please just tell me whether my audio, video, everything is clear. You can just chat here. Hello, Sahil. Good evening. So please join quickly and you can just say hi or hello. Yes. Am I audible? Sahil, am I audible? Okay, that's great. Okay. So now let's start the session. So before I begin the session, you can just share the class information with your friends, this YouTube link, and please join in my Telegram group, and also do subscribe the channel and just press the bell button for getting notifications related to all the classes we are providing at BYJU'S exam prep. So we are providing classes for NIELIT, classes for GATE, and also some general sessions and post-GATE guidance, coffee with concepts. So a lot of sessions we are providing. So you can just share with your friends, and if you are not yet subscribed it, you can just subscribe the channel. We have more than 4 lakh subscriptions for GATE and computer science and other branches. Okay. So in today's session, I will be teaching basics of finite automata in theory of computation. Okay. So if you have any sort of doubt, you can just post your doubt. I will just clarify your doubt. Yes. Okay. Now coming to, before I start the session, so let me introduce myself. Myself, Murali Krishna Bokkasamudram. I am having 21 plus years of teaching experience, and I am topper in NPTEL course of theory of computation, and that's what I am teaching you right now. And I am also certified as international engineering educator through ISRO certification program. And I have mentored more than 50,000 students across the country in different core areas of computer science and engineering. That is theory of computation. That's what I am teaching you right now. Operating systems, computer organization, computer networks, digital logic, and ICT, information and communication technology. So these are my area of expertise. Okay. Yes. Now let's move on to the session. And today's session is very important. You will learn the basics of the abstract machine, that is a finite automata. So what is a finite automata? What are the entities present in finite automata? The things I am going to discuss. So just before that, you can just have a look at the scholarship test we are conducting. You can take a step towards success in the GATE by registering the scholarship test. You can get up to 90% off on our programs once if you excel in this scholarship test. It is on par with GATE level. It is exclusively for the GATE exam, and it is on 30th April, that is on coming Sunday at 12 p.m. You can attend the exam. You can register right now. Okay, and if you have any doubt, any concern, you can just chat with me directly here. And yeah, and these are our toppers. So we got more than 62 students under All India rank 50 in the 2023 GATE year, and rank under 10 we got 13 students. Under All India rank 100 we got 107 students, and these are our 3 toppers. All India rank 5th rank by Dhruv and in computer science, and SH Gautam has secured All India rank 1 in P&I, and Sarvarma has got instrumentation 4th rank and Triple E 5th rank. So big congratulations to all these toppers, and let's just congratulate all these toppers once again. In addition to that, we are also having some major students who have taken coaching at a series here are qualified, and also I'm wishing you all the best for 2024 GATE aspirants and also NIELIT aspirants. Okay, now shall I continue? Yeah. Okay. So I hope every one of you are able to hear my voice and audio, video, everything is clear. Now coming to this finite automata, as I told you, it is to accept regular languages. Finite automata, we can say it is a mathematical model of a regular language. So regular languages can be basically RL means regular language here. Regular languages can be expressed in the form of a regular expression. So we can convert the regular expression into finite automata. Finite automata is the machine counterpart for the regular languages. What do you mean by a machine counterpart? It is an abstract machine. It is not a physical machine. It is an abstract machine for computing the regular languages, for accepting the regular languages. So when can we say that when language is regular? If it can be recognized by finite state machine. There is no difference between finite automata or finite state machine. So in general sense, automata is nothing but it is a model or it is a machine or an entity. It is doing the activities on its own. That is a general meaning. But in this context of formal language theory, automata is nothing but it is a mathematical representation of formal language or machine counterpart of formal language. Like finite automata is a language recognizer of regular language, and pushdown automata is recognizer of contextual language, like that. Okay, we have seen the hierarchy of formal languages like regular, finite automata, and linear bounded automata Turing machines are powerful than the finite automata. Okay, so finite automata basically it is also called as the finite state machine. So the number of states present here are the finite, and finite automata has no temporary storage, and hence it cannot remember finite information with the help of finite control. It will just having the states and transitions only. Only the input string we keep on the input tape, and using the read write header we can just read the input and moving forward till you get the final state or ending of the string. Okay, so this is how we represent the finite state machine, an abstract machine. Okay, so in general these machines are used in the text editors and the compilation process. So when you take the design of compiler, there are different phases. Lexical analysis is one of the phase. In that lexical analysis, all the keywords, reserved words, okay, used in the programming language can be represented with a simplified DFA. Okay, so if DFA, that deterministic finite automata, accepts that string, then it will be taken as a valid, otherwise it is invalid. So it will show the error in the compilation process. In addition to that, it is used in the security of network, okay, in deep packet inspection, for pattern inspections, to avoid the packets which are containing malicious information. And also this finite automata is used in the text editors and debugging. There are so many other applications, but in this context, theory of computation and finite automata are used in the design of compilation. Okay, so yes, good evening Nishu Kumar, good evening. Hope you are following. I hope I am audible and visible to every one of you. So now let's move on to the next page. Basically, finite automata accepts a regular language as follows. It is like this. So finite acceptor will be there. If you take any string as an input, okay, so the output should be output in the sense we have to identify or determine whether it is accepted or it is rejected. Accept the string if the string is given in the regular language. For instance, yesterday we did discuss a lot of regular expressions. Yesterday's class, day before yesterday. For instance, if we take a language L is equal to something like I am writing a power n, some b power m, such that n is greater than or equal to 0 and m is greater than or equal to 0. Here, what is the alphabet for this language? A comma b. So minimum string is epsilon is possible, single a possible, single b possible, ab possible, aab possible, okay, abb possible, like this. So 0 or more a's followed by 0 or more b's. Regular expression like a star b star. 0 or more a's followed by 0 or more b's. Okay, so finite automata, if you construct for this, just example I am telling you. If you take any string present in the language, something like, for example, a, b, b, it is a valid. One instance of a followed by two instances of b's. So if this is the string, then it will say accept, it will reach to final state. Okay. If you take a wrong string, something like, for example, ABA is not present in A star B star. So it won't accept, it will reject. That means it will go to non-final state. If it goes to final state, we will say it is accepted. If it goes to non-final state, we will say it is rejected. So accept string if string is in the given regular language. So if it is present, so ABB is present in the given regular language L, but ABA is not present in the language, it will reject if the string is not in the given language. Hope you are understanding. So very basics level I am teaching this class for understanding what is a finite automata. But when you go to some advanced topics like constructions and comparisons. So more typical problems we will discuss. Okay. Yes. Hi Tarun. Namaste Tarun. So please do share this class information with your friends, and also you can do subscribe the channel if you have not yet done it, and also do like this session if you are really liking it. Okay. Now coming to this one, Finite Automata accepts a regular language as follows. So input string over the input alphabet, and it will be inspected with the transducer, and output string over output alphabet. Finite Automata can also generate output. That is called Finite Automata with output. There are two machines, Moore machine and Mealy machines. And normal Finite Automata without output, just it will say accepted or rejected with the final state. But in the Finite Automata with output, in response to the input string, we generate some output string. So for some computations, we require to produce output based on the input. So that's why it can also produce outputs. Okay. So that is the Finite Automata accepts a regular language like this. And configuration of Finite Automata, just graphically we can represent. We can say it is a graphical representation of finite state machine. So what is a graphical representation of finite state machine? Header moves from left to right direction, as I told you. So header is keep on moving from left to right till you get epsilon. Epsilon means ending of the string. Only we perform the read operation here, and finite control controls the total operation. Finite control controls the total operation. For instance, let us suppose we are having AAABB is a string followed by epsilon. So initially we will be in some state, and when input A comes, what state will reach you have to define, and always it moves to right side, and it keep on moving to right side till you get ending of the string, that is epsilon. So whenever epsilon is encountered, so if means when the string is ended, if a resulting state is final, it will accept, otherwise it will reject. And the header will not move to left side, it keep on moving to right side till ending of the string. And we don't remember the inputs here, we keep on just looking at what is the present state and what is input, and defines what is the next state. Okay, now hope you are following. This is the graphical representation or abstract view of the finite state machine. Abstract machine. Abstract means it is not a physical machine, it is just logical. Okay. Now coming to input type contains a string over the given input, as I told you, like A, B's or zeros and ones, etc., based on the alphabet. And it reads head is pointer, which reads one input symbol at a time and moves to the next symbol. So after moving to next symbol, we can decide whether it is accepted or not accepted based on the ending of the string. Finite control contains set of finite states and transitions functions to take an action, whether based on the resulting state. For every string, the finite control starts from an initial state only. To begin with, initial state will be there. Usually that is a q suffix 0, q naught. And we represent finite automata states circles. Non-final states are the single circle, final states are represented with double circles. Okay, now? So shall I continue in the next page? So equivalence of finite automata. What do you mean by, see, there are different representations actually. So for making the construction process easy, so we go with this cycle. Any regular expression, if you know, regular expression is possible only for regular languages. For non-regular languages, regular expression is not possible. We can construct a non-deterministic finite automata with epsilon moves very easily for a given regular expression. NFA epsilon moves. All are equivalent. NFA, epsilon moves, DFA, NFA, all are equivalent, but only representation difference. For making the construction procedure easy, we will come through this procedure. Our intention is to construct the DFA, so which is very difficult to directly construct. That's why we will come through this procedure. So finally, minimized DFA we are going to implement. So NFA, there is a procedure to convert into DFA, and DFA also there is a procedure to convert into regular expression. This is the cycle. NFA epsilon moves is a basic thing where if you see the regular expression, operators like union, concatenation, clean closure. So using this NFA epsilon can be constructed easily. So all the three machines accept the same class of languages, and the power of all the machines is same because they are acceptors of regular languages. Power of machines is same in the sense their accepting capability. They can't accept the non-regular languages. They can accept only regular languages. For instance, L is equal to some a power n b power n such that n greater than or equal to 0, it is a non-regular language. We can't have a finite automata for this. Finite automata means either NFA, epsilon moves, NFA or DFA, but at the time of implementing DFA only we use. Okay, hope you are understanding, and please do share this class information with your friends, and please do like this session. And basically every DFA is also having a special case of NFA, we can say. NFA can be converted to DFA by using some subset construction. Epsilon NFA also can be converted to NFA, and NFA also can be converted to DFA. And these are the entities present in the finite state machine. You can just have a look. Representation of finite state automata. Finite automata contain Q, sigma, delta, Q naught and F. Those are called 5 entities. That's why it is called a quintuple machine. This is called a quintuple. Tuple is nothing but entity. So how many entities are there? 5 entities. So here Q indicates set of states, sigma is set of inputs, delta is a transition function, Q0 is the initial state, and F is the set of final state, where F is the subset of set of states. So either all states can be final or some of the states can be final. So Q is the finite set of states, and sigma is input alphabet contains finite number of inputs. Delta is a transition function defined over transitions of FA for the state and inputs. Like delta is from Q cross sigma to Q. So what do you mean by this delta? Q may be any state in the set of states. Sigma may be any input in the set of inputs. The resulting will give any of the state. For instance, let us suppose there is a state Q0 and there is a state Q1. Let us assume we represent with circles and transitions with arrows. For example, if I mention Q0 on input A is equal to Q1, we just write the rule as transition of Q0 on A, it goes to Q1. It means that when the machine is at state Q0, when input A is encountered, it moves to right side and it reaches to the state Q1. So that is what transition function. So delta is from Q cross sigma to Q. Q indicates any state in the set of states, sigma indicates any input in the set of inputs. And Q0 is initial state. To begin with, we have to start with one initial state, and we may have multiple final states. That is what it's called, set of final states. And the string will be accepted if there is a path from initial state to final state. I will show you some examples also how the strings are accepted here. So state transition diagram, one example you take, Q0 and Q1, X and Y are the inputs. So what are the set of states here? Every state represented by a circle. For an initial state, a circle is associated with arrow, which is this one. This is indicating starting. And final states are represented with double circle, and every state is connected with a transition associated with input. So like for example, alphabet sigma is equal to X comma Y. Set of states Q0 comma Q1. Initial state is Q0 and it is a final state. There is only one final state. And what is the delta here? Delta is nothing but transition function. So delta of Q0 on X is a Q1. Q0 on Y, it is Q0. Delta of Q1 on X, it is a Q1. Q1 on Y, it is Q0. Like this, arrow mark. Okay. So it is like this. For example, if I am taking something like XY string followed by epsilon is ending. So initially we begin with initial state Q0. Q0 on X, it is defined as Q1. So it moves to right side, header moves to right side. It reaches to the state Q1. Q1 on Y, it goes to Q0. It goes to Q0. Move to right side. Q0 on X, it goes to Q1 again. And Q1 on Y, it goes to Q0. So Q0 on Y, it is again Q0. So whenever the string is ended, we are in a non-final state. So Q0 does not belongs to final state. So this string has been rejected. XY, XYY. XY, XYY. We are in Q0 state. It is not being accepted. Hope you are following. Yes. It will not go to final state. Sahil, you are right. Okay. Are you following? Yes. So shall I go for the next page? That's great. Okay. Now coming to state transition table of the same thing, it is like this. Table contains rows and columns. Okay, so each row corresponds to state in the DFA. DFA means deterministic finite automata. So in deterministic finite automata, every state will have input only once, but all inputs are required. Each column corresponds to input symbol. So it is like this. So Q0 is the initial state. Okay, Q1 is the final state. Actually, this is a Q1 is a final state. We can represent with a star. This is a Q1. The star representation is final state, or we can show with a circle, double circle. Q0 on X is Q1, Q0 on Y is Q0. Q1 on X is Q1, Q1 on Y is Q0. So in a DFA, every state and input, only one reaching state will be there. But in a non-deterministic, we may have multiple reaching states. Okay, this is only representation I am telling you how it is accepting language and all. If you practice the finite state machines for a different set of languages, you can understand that. Okay, now coming to, yes, if you have any doubt, you could ask me meanwhile. And the types of finite automata is a normal language acceptor, that is finite automata with output, without output and with output. So finite transducer and finite acceptor. Finite automata without output is what I have shown you, XY inputs, no output there. Only accepted or rejected we can say based on whether it is reaches to final state or not. And finite automata with output means in response to input, it will generate output. That is, two machines are there for it. For a non-output, without output, deterministic finite automata, non-deterministic, and epsilon and FA already I have shown you. The power of all these machines are same. And Moore machine and Mealy machine are the two categories of machines which we use for machine to generate some output in response to some input. Okay, now? And do you have any doubt? Please ask me. Yes, Mealy and Moore machines. They will generate output in response to some inputs. Okay. So now coming to a machine which accepts or recognizes language, that is called acceptor. Transducer means a machine which produces an output. One example I'll tell you, language accepted by finite automata. So language accepted, this is the definition. It means that L of M is nothing but M is a machine here. Language accepted by the machine is equal to X such that transition of Q0 on X is in F. So it means that in response to the string X, when you start from initial state Q0, if the resulting state is one of the final state, string will be accepted. Otherwise, string won't be accepted. That is the criteria. You can see. So, for example, if you take an example here, I will show you. Let us suppose there is a state Q0 and there is a state Q1. Okay, and Q0 is the starting state. And we are having inputs like this. Input A is there and input A is there. And input B we have given as a self loop, for instance. This is one finite automata. Okay, so just I wanted to show you how it is accepted or how it is rejected. Say for example, X is equal to the string ABAA, for example. ABAA, how it is represented, let's see. ABAA means transition of Q0 and X. Q0 is initial state. Every string should start from initial state. Q0 on ABAA. So what is a Q0 on A? It goes to Q1. So it would be transition of Q1 comma. It moves to right side now. Next symbol to be accepted is B. So Q1 comma B now. What is a Q1 comma B? Q1 only. So transition of Q1 comma AA. Now Q1 on A, it is a Q0. So this is a delta of Q0 on A. So Q0 on A is equal to Q1. So Q1 belongs to final state. So that means it is accepted. It is accepted. It is accepted. If a resulting state is non-final, it won't accept. That is the meaning of L of M. For instance, if I am taking string X is equal to something like AAB, it won't accept. Transition of Q0 on AAB. Q0 on A, it goes to Q1. So it is a transition of Q1 comma AB, and Q1 on A it goes to Q0. So this is a transition of Q0 comma B. Q0 on B it goes to Q0 only. So Q0 does not belongs to final. So this is rejected. Like this we can say string is accepted or rejected. Hope you are following. Shall we go for the next page? Let me know, please. Yes. And those who have not yet subscribed, please do subscribe, and please do like this session if you are really liking it. And bell icon you can press for getting the notifications. Okay. So shall I go for the next example on the language accepted by the machine? So there are different machines. So actually how we can represent this machine? Delta. So delta of this machine we can represent like this. Input A and input B. So Q0 is a non-final, Q1 is a final. Q0 on A is Q1, Q0 on B is Q0, and Q1 on A is Q0, Q1 on B is Q1. So what did you understand from this? Q0 on B is Q0, Q0 on A Q1, Q1 on A is Q0, Q1 on B is a Q1 only. What did you understand from this? We have to construct a machine based on the language actually. How to construct based on language I am not telling you. Just I am telling you how we can just show the representation of machine and how it is accepting a string, rejecting a string. That you have to understand first basically. Then design procedure we can see later on. Okay na? And these are two states machine. Coming to one example of finite automata. Let us suppose I am having something like a machine like A of BA whole star, for instance. A of BA whole star is containing what type of strings? A is one string, A followed by BA is one string, A followed by BA BA. So BA BA is keep on repeating 0 or more times. 0 or more times. So what is the smallest string accepted here? Smallest string accepted is A. Okay, so from Q0, Q0 should not be a final state. If Q0 is final state, for example, if a starting state is a final, it will accept epsilon, null string. Okay, and Q0 on A, it should go to final state. You see, now A is accepted. After that, BA should be repeated. There are two ways of doing this. So BA repetition, I can do a loop like this. It is not a DFA, just a finite state machine. So Q0 on A is accepted, then BA BA repeated. So Q2 is a non-final state. So A accepted, and after that BA accepted, BA BA repetition. Same thing we can also represent with the two states. Okay, M2. Two states it's like this. So Q0 on A, it goes to Q1. It's a final state, and A B A B we have to go back like this. So A accepted, A BA accepted. A accepted, A BA BA repetition. So whatever the language M1 is accepting, that is L of M1 is the same as L of M2. So language accepted by machine M1 is the same as language accepted by machine M2. Okay. This is just as an example I am telling you. Similarly, if you are having something like AB whole star, for example, that is not a DFA. If you wanted to convert into DFA, that state is to be introduced. That we will discuss in the DFA chapter. Just it is finite state machine. It can be NFA also. So AB whole star is nothing but epsilon, AB, 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 and so on. These are the strings. Are you following? So in this, we can do as epsilon is there. So we have to take starting state as a final state. Then we have to accept AB repetition now. Single A should not be accepted. So single A, we have to go for a non-final state, and AB can accept. Epsilon accepted, AB accepted, AB, AB, any number of AB sequence can come. Is it clear? Or any doubt or any concern? Let me know. This is example of finite automata. And one more example. Let us suppose we are having a machine like this. Let us suppose A plus B whole star A. It is all combination of A's and B's ending with A. All combination of A's and B's ending with A. So you can observe carefully. So the starting state is not a final state because the minimum string should be A. Next we can have AA or BA, okay, ABA and BBA and so on. This type of strings can accept. So Q0 on A, it can go for Q1, is a final state. And before this A, any combination of A's and B's. So we can give the A here, and just I am trying the DFA just. So A accepted, AA accepted, any number of A's ends with A only. So before this A, we can put B here, any number of B's can accept, and Q1 on B also goes to Q0. It is like this. So the strings accepted by this were like this. So A is accepted, BA is accepted, okay, AA is accepted, BAA accepted, ABA accepted, like this. So any string of A's and B's ending with A. Any string of A's and B's ending with A were accepted. Okay, na? So this type of strings actually we can represent in the finite automata. Okay, only regular languages were accepted. So just let me know if you have any doubt. Do you have any doubt still? Yeah, two states. You're right. Okay. So that's all for today. Hope you people have enjoyed the session. And tomorrow also we are having a session on the non-deterministic finite automata at 9 p.m. So please do attend at 9 p.m. tomorrow, and you will definitely enjoy the session. And please share with your friends and do subscribe the channel. Thank you so much. Thank you, one and all. Have a good night. See you once again tomorrow.